Hello, everyone. Thank you all for coming to another online tech talk in YPrompt. The topic that we are going to be discussing today is a tool that we use extensively called Locust that we use to test the performance of the infrastructure, stress test it, and also something that's very important to us from the DevOps standpoint, it's that the resources scale as they should when they are under load. This also helps on the application end to test the life cycle of a user within the application. Just a few quick summary of what an OTT is. These OTTs either comes from something that we were working on, in this case, which is that we use Locust in some applications, something that you might have researched it or read in a blog post, or something that you found out about technology updates, such as new frameworks or features or tools that you found out. If you have any questions during the presentation, please go ahead and stop me. So first of all, we're going to be talking about the benefits and use cases of Locusts. Then I'm going to be showing you a short example of Locust files that we're going to be using in the example product. But just so you are all aware, in the DevOps area, we're also working on templating the Locust process. So in the future, it will be very easy to be used by any other application like a starting point and make their own Locust files and Locust tests for their own purposes. Then I'm going to be showing you a quick look on how Locust starts, how it works, and what we measure from our end to see, well, the stress in the infrastructure and to actually verify that it is working as we expect, or that it or how it helps us to know when we are over provisioning or under provisioning resources. And then we will have a question and answer spot if you happen to have any questions. First of all, the benefits and use cases of Locust. The first benefit, it's written in old plain Python. So that makes it, well, at least in my opinion, very easy to use since Python, it's not a very complicated language. And you can also use the regular programming constructs that you're used to using, such as looping, conditional behavior, and calculations. And there's no need for callbacks or alternative mechanism. Locust runs every user with its own lightweight greenlet routine. This also makes it distributed and scalable. The load tests can be distributed across multiple machines or multiple Docker containers, so that you can actually make a swarm if your application needs to test thousands of users. The event-based architecture enables single process to handle thousands of concurrent users. And even though there might be some tools that may achieve higher requests per second, Locust has a very low overhead, which makes it usable on any type of infrastructure that you want. You can run it locally, you can run it on scaling group on a couple of EC2 instances, wherever you see fit. More benefits is that you can either run it through a web-based UI, or you can integrate it into CI/CD testing workflows, or if you prefer to run it locally unattended, you can also do that. So it fits all the needs. It also has a lot of versatility across systems. The other benefit is that it's hackable and flexible. Since it's very small and flexible, it is very easy to be customized to hit your own APIs or REST APIs as needed to test all the parts of your application. I'm going to be giving you a quick example of some Locust files. Again, this is an example of complete testing framework that we did in Locust that tests almost all the parts of our application. So it may look big, but you don't need to start as big as we are. Again, as I remember, we are completing a project in the DevOps area to have a template for this as a starting point. So it will be a lot easier for new Locust use cases to use the tool. Complete project looks something like this. The file that Locust cares about is the one that's called locustfile.py. Again, this is the default name that Locust is going to be looking for. You can name it whatever you want, and then with the flag -f, you can call whatever you set up the Locust file. But as a good practice, I recommend using the Locust file there. Now, in here, the way that we have it separated is that it works with a user class that is separated in its own user file.py. As you can see here in the Locust file, what we are doing in this case, since again, it's a very big project, a very big test framework, we separated the queries and the mutations in their own folders and also in their own files because it makes it easier for us to then work on each of them individually as we see fit, depending on the tests that we are running. For example, if you having them separated, once you see the report, makes it easier for you to see which of the steps of these queries or mutations is failing or causing the most failures during your tests. Now, this is an example of a queries file. You see here that this is the definition of the query with the format that it is expecting. And then here, this is something proprietary to Locust. You define the task, which with what it is going to use. Here, we need the header for the authorization token. In our case, for the tests that we've been running, the current application that we are testing it uses Cognito for authentication, but on the beginning, we were using username and password authentication. So it supports both of those methods. Then this is a mutations example. Again, a very self-explanatory query using GraphQL. Oh, one thing that I forgot to mention. On all of our test cases, we've used GraphQL, but it works with regular REST APIs also. And then again here, a Locust file.py example. In here, you define the class of load testing that you're going to use. That depends on the user class that is defined in a separate file, which I'm going to be showing you in a second. But the actual tests and the path of each user that is going to be spawned by Locust is going to be using the Locust file. Here you see how the user class is defined. This is used by the load testing part to actually spawn each user with this configuration. In the Locust documentation, you will be able to see, depending on how you define this user, the versatility that you need to use it depending on your requirements. Now, I'm gonna go ahead and show you like a real test case now. So, for starters, you will see that I'm on the same directory as before. So I'm going to run the command locust. Obviously, you need to first install locust using pip. Since I'm on Mac, I used pip 3. But depending on what you're using, you can use the regular pip or even brew. So when you run locust, you see that it starts a local web server, which is where the UI is going to be used. Again, this is working this way because I didn't pass the unattended flag. So it's going to be waiting for me to use the UI. And when we log into here, we see the amount of maximum users that we want to be running against our application. In our case, we're going to be using 50 as a maximum amount. And here, the spawn rate for each user. This completely depends on what you want to test and how you want to test it. For example, in our application that we're currently testing it with, we are testing with a 0.25 spawn rate for users. This means that we are going to have one user per 4 seconds. That's since we are not going to have many concurrent users or logging in at the same time, this fits our needs. But there are other projects where you would want even a slower spawn rate or a higher spawn rate. So I'm going to give it 1 per second, and this host that you see here, you can either write it or it can be taken from the end file. I'm not going to be showing you the actual end file because it has our access keys, but we have this example here. This is where the host URL, where the URL that we are going to be hitting with our tests, the minimum wait time and maximum wait time between queries for each of the users. This that means that it is going to be selecting a random amount of seconds between each query that is going to be running. And again, all the other requirements to log against Cognito and AWS to be able to actually run the queries. To add a little bit more to this, you can see here that we had to define the Cognito class to actually be able to, well, authorize against Cognito to get the token and to be able to pass that to our simulated users to be able to connect and test against the API. So once we hit start swarming, the first tab that we have is the statistics. Again, you here will be see, since we separated each of the queries, each with their own name, which is again, one of the best practices, we will be able to see them all here, how many times they were requested, the amount of fails per request, again, medians about response times. We have a lot of information here, and the size of the request. The other part that is also very, very useful is the charge part. We can see here the total requests per second, the response time for each of the queries. Again, you may see here, for example, if you have a Redis or another caching layer in your application, you will see a slower response time as a start, and then it will greatly go down once the information the user requesting is already cached. And the last chart, it's not as useful as the others, but it tells you in the graph across the time where you're running the request, the amount of users that you had. If you happen to have any failures, which we have at the moment, this is something that we are currently working on due to the stress, you will see which exactly of the named queries or mutations that you have are failing. If you happen to have any exception, you're going to be able to see it here. Also, something very interesting, in this case, the way that we have the tests set up, we expect each of the queries and mutations to be run the same amount of times. But if you have a part of your user lifecycle that is more important, you can add more weight to that part, and you will see a higher percentage of those queries being run against the application. And then either after you stopped the stress test or even during, you can download all the request failures and exceptions, and then the report, which is in an HTML format and also has the same feature as this one, where you can put the mouse cursor and it will tell you exactly what the RPS was, the failure, and the users at the moment where you are passing your cursor on. Now, the way that we use this for DevOps is that we want to see the actual usage. As you can see, once we started the tests, you can see that the memory utilizations has started to rise, and also the CPU usage has started to rise in our ECS cluster. Now, regarding what I told you at the beginning, that we also use this to test scalability, we are not going to be able to see it here, but in this deployment part or event parts in the ECS monitoring, you will be able to see here also in the tasks tab when a container is starting, how many pending you have, how many desired you have, depending on how you are stressing your infrastructure. This helps you to test that your application is scaling out or scaling up as you want it to, or tune it as you see it fit. For example, when we started running the Locust tool on November of last year against our Axom application, we noticed that the database tier that we were using worked perfectly for about up to 30 users, but then the CPU usage got very high and the database was not enough. So we had to increase the tier of the database. So the metrics that we use in AWS to actually measure how everything is working while we are running the stress test is, for example, we have an Aurora cluster with a read and write distance. So we see if there is any noticeable lag in the requests between the replicas, if there's any commit latency, buffer cache hit ratio, the commit throughput, depending on the amount of users that we're going to have, this should increase. And if we have the correct size of the database, this should stay on a regular level and do not cause any issue, any delays on any of the other queries. And since, for example, in our case, we're using a burstable instance, we will see the credit usage move very slowly down or up, depending on how we are stressing the database or the cluster. The other part that you can also look into, which is also very helpful, is the load balancer metrics. Since we are going to be able to see here if we have anything that we are not expecting, for example, 502s, 500s, 400s, and any other issue that we see. We have a good amount of 200 connections, which is what we are looking for. And if we start to see a lot of 500s, 400s, we know that there is a problem when we are receiving the request. We also have here on our application Container Insights enabled, where we see in more detail how the storage is used, the number of desired tasks. Again, once this is getting more stress, the amount of desired tasks will go up, the name of running tasks will go up, and pending tasks, again, depending on the time, should go up, and then the task requirement should be fulfilled by our scaling settings. Now, once you stop the test, you can, as I mentioned, download the CSV as you see fit. And what's nice about this is something that we set up on our current testing framework to actually log what it is doing. But what I wanted to show is that once you stop the process from here, you also have the metrics, I mean statistics that we saw in the console format. So if you need to or prefer to, you will also see it here. And again, this is the same format that the reports, if you download from this part, you will be receiving them. If you run it in an attended mode, you can specify which reports you want to be outputted during your tests or after your tests and the name of those files. So there's no need for a UI. Again, it can be integrated into a CI/CD pipeline. So let me see if I'm missing anything. Again, running Locust file locally, I already showed you this. This is the UI. Some example of the graphics that you will be seeing. The response time, again, I avoided the user because since you are already going to be seeing the users, or I mean the requests per second here, which is a metric that we're interested in, the amount of users is also an important metric, but probably not as important as the others. And again, what I told you just before, that you can also see the statistics in the console. Very high level summary of what Locust is, how we used it in the DevOps area to check that everything is scaling as it should and performing as it should, and a bit of facts that it is very flexible. You can do anything you want with this framework and run the tests as you see fit. The only thing that we haven't used so far on our end is actually making a swarm of Locust instances to run against an application, because we haven't had an application so big that needed more than one Locust client running against them. We're able to, for example, on my personal Mac, I am able to run 1,000 users without any issues against the API. Does anyone have any questions, concerns about Locust and what I just showed you?
Not a question, but a comment.
Yeah.
Seems to be really interesting, and I think it's a really good practice to do this in most projects. No, it would be nice.
Yeah, I think it is. That's why we are working on a template to have something that is the best starting point for any application, so that we have like a skeleton project that then can be used by any application. Again, the way that we use it, since it comes from our DevOps area, as you may imagine, you as a DevOps, you need to work closely with the developers, because the developers know how the application works, and they are the ones that are going to help you to run the user lifecycle, and they are going to need to give you the endpoint. They probably have a Postman collection that you can use as a starting point to run to start writing your mutations and queries and stuff like that.
Interesting.
Locust web page, which again is great. The documentation is amazing as far as I was able to check. One thing that I forgot to mention, very important, it is you can run this on Docker. So you could probably run this on Kubernetes and ECS cluster, a couple of Docker running inside EC2 instances, whatever you need and is fit for your application.
Great, thank you, Marcos.
You're welcome. Any other questions, comments, concerns? I think we are right on time. Thank you everyone for attending. Have a nice day. Bye-bye.